Okay, so in the last video we talked about taking a buck converter, reverse engineering it, and trying to make our own circuit with it. So it is this guy right here. Not a whole lot of components on this, so I think it's going to be relatively easy to reverse engineer. So yeah, we'll get this under the microscope and take a closer look at it. Okay, so we've got the inputs in positive and in negative. This can handle anywhere from 5 volts to 30 volts on the input, and then it'll wind up bringing it down to whatever voltage you specify. There's a couple of filtering capacitors, the big one there and that little brown one right there. We've got, I'll have to look at what this is actually. Oh, it's a voltage divider. Okay. So it's a 1.8K resistor feeding into a 50K potentiometer. And this guy right here is where you're going to adjust for your output voltage. Then we've got the heart of the buck converter, the XL Semi XL4015E1. We have got a toroid coil. I think this guy is going to be 33 or 47 microhenries. We have a 512 ohm current limiting resistor for the LED. A couple of output capacitors, output filter capacitors, sorry, and a diode. So looks pretty straightforward. So give me a minute and we will switch back to a different view and go from there. Okay, as I was going into reverse engineer that buck boost converter, I decided to go take a look at the XL Semiconductor datasheet. And there happened to be an application circuit, and I think what we're going to do is loosely base our schematic off of this. We'll start out in EasyEDA, get this all configured up, and then with any luck we will ship these off to be manufactured and come back in a week or so and try to put these together and hope we don't let out the magic white smoke. So give me just a second, we'll switch over to EasyEDA. Okay, we are in EasyEDA now. This is the basic layout, I guess, for their schematic. So I am going to just kind of put in my information here. All right, so looking at this, the first thing that we've got is the capacitors. Well, the first thing that we need to do is create a VN and VOut. So we'll do VCC, that's voltage in, we'll do ground, and I'm probably going to wind up fast forwarding through most of this, so probably not a whole lot of talking while I go through and put this together, but I'll speed it up so you guys don't have to sit through the whole thing. So that's pretty much it. From this point, we'll upload it to them, see if everything goes okay with it, and then we will go from there. So probably see you in a week or so. And that, in fact, was not it. So there was some more that I forgot about. So now that we have the actual schematic done, one of the things that we need to do is create a PCB board. So we're going to convert this to a PCB. Oh, I gotta save it. Alright, let's try this again. Alright, So now what we got to do is move all these parts in and get them adjusted properly. So this will take another few minutes to go through the design here and move all these where they need to be. So one moment please while I do this. I'll go ahead and pause the recording and I'll come back when it's all completed. Okay, so here is the completed PCB layout. Red traces are on the top and blue is on the bottom. So everything looks like it's laid out okay. There's a cool feature in this that lets you get either a 2D or 3D view of that board. So that looks relatively similar. Let's go look at the 3D view, and this one's actually really cool. It kind of populates as much as it can, and you can kind of rotate it around, take a look at it, and make sure everything looks okay. So yeah, now we're actually at a point where we can send this off to be manufactured. So we'll do that and see you in a week.